Hi folks, so the question we have in front of us here today, guys, is based on the World of Graphics textbook, chapter 16, page 265, and it comes under the chapter on developments, okay? So we can see here we've obviously got a 3D graphic of it here, a pictorial view, and another pictorial view of it down here with the measurements, okay, the isometric view. It says, question 7, a tape dispenser is shown below. Draw A, an elevation in the direction of arrow A, a plan projected from the elevation in the direction of arrow B, and then the complete surface development for part C of the tape dispenser. Okay, so looking at our object here, obviously, first of all, we're going to focus on the orthographic, which is what it's asking us here, because it's asking us for the elevation and the plan. So when we look at the elevation in the direction of arrow A is pointing to the left. Usually you put your elevation on the left hand side of the page. Okay, work out the overall length. We can see it's the distance from here to here is 20. Okay, it obviously comes down a little bit, it tapers downwards towards this corner here. I say corner, where the circle actually starts is what I should say. So the distance here is 20 millimeters, then it comes another 60 over as far as here, which is where our center of our circle is going to be along that line there. And then the radius of that circle has a radius of 30 and it has a hole inside of radius 10. So overall 20 plus 60 plus the distance here, which is 30, that altogether adds up to 110 long. And the overall height of it then, if the radius here is 30, the overall height of it is going to be 60. Okay, so that's going to help us draw in our elevation. And then the plan of it then is just going to be 40 wide, and it's obviously going to curl up here. And we can see it kind of stops here. So it's essentially, we've got this curved surface at the back when we're going to be doing our development, okay? So we have to think of how we're going to be able to complete that. So starting off the question there now, I'm going to start off by drawing the elevation in the direction of arrow A and project my plan from that. Okay. So, just going to zoom out there, and I'm going to keep my XY line, and I'm going to start my XY line roughly just about halfway. Yeah, start halfway up on the page. So I'm going to make sure it's long enough as well, and I'm going to keep it on the left hand side. So about there, I think that'll do it. So XY line, and what I'm now going to do is put in my measurements. So I know my overall measurement is 110. So I'll put that one in first. So 0, I'm going to mark to the 110, and then I'll put my other ones in between, and I know it said 20 plus 60, and obviously we had 30 left over. Okay, so starting off, the height of it at the front was 40 millimeters. This portion going up here went up a distance of 40, and the height for the center line was up 60, because that is my diameter of my semicircle at the end of it. So I'll mark up to the 6 and I'll mark at the 3, and that should enable me then to put in my semicircle. So from here down to here, and there we have it. Okay, so just matching up those. Happy with that, just checking that it's accurate. And then what I'm actually going to do is just looking at the drawing there. Oh yeah, so this connects down here like this from where I marked up 40 millimeters. Okay, it connects down like that, and at that point there I'm going to mark up a line as far as the 20 here, and at that point right there, that point then connects up to the top of it up here. And there is our object. Okay, so what we had to do was from the 40 mark, I had to do an inclined line down to the bottom of my diameter. So I can heavy that in now. And then heavy in the curve. So I'll just switch out my pen there in the compass. So there we have that, and now I'm just going to put in the measurement then for the hole on the inside of it. Okay, and I think it has a radius of 10. Just check that. Yep, radius 10. So just put in this now here. A little bit awkward obviously with the compass when it's a smaller hole. Do the best I can. There we have it. And there is the elevation completed of our tape dispenser. Now from the elevation it said we have to project a plan. Okay, so when we're looking down on top of it, what do we see when we look down on top of it? So I have my overall length here already, and here. And what I'm going to do is I'm going to keep a distance between my view, okay, the elevation and the plan. I'm going to keep a distance of about 10 millimeters. And I know then from here the width of the object is 40 millimeters down. So from there I'm going to mark down 40, and there you have it. There is the overall outside shape of our object, okay, of our tape dispenser I should say. So I'm going to heavy in this. Now that edge there, okay, because when you look down top of it, I know obviously this is a curved portion here, but we'll see where the curved portion finishes as it curves around and curls back into itself. As these curls around and curls back into itself, we would see that edge where it obviously stops curling and before it curls back into itself, we'd see it as an edge. Okay, so heavy in this, and finally heavy in this. And one last little bit, I have an edge up here at the very top, which I will project down, and then just heavy in right there. Okay, and obviously then we have a hole running through it. Okay, so if I was just to put that in, there would be, that would indicate to us where the hole is, here and here and here and here. Okay, that is the width of the hole. Okay, so now at this point what we actually have to do is we have to be able to set it up for our development. Okay, that is part A done and part B done, the elevation and the plan. So for our development, possibly the easiest way to actually develop this out is first of all count the amount of surfaces. Okay, so on the object we obviously have kind of like this face here at the front. Okay, we've obviously got these faces here, kind of the sides of it. Okay, we've got two of them. We've got this face here at the front, so I'll just write these in actually. So I'm going to say, and I'm calling these, okay, I know it's the front elevation, but it's kind of the side of it, so I'm just going to say 2 by sides. Okay, so we've got 2 sides. We have kind of the front face, so 1 by front, okay, which is going along here. Okay, we've kind of got a bottom surface here, so 1 by bottom. And then finally, okay, so the 2 sides, we have the front, we have the bottom, okay, so 4 altogether, and then we have this curved surface here, okay, which is probably the trickiest part of this question. So we have 1 by, I'm going to put in C, I'll actually write it in curved, and then just say surface. Okay, so that's what we have to do to complete our development, alright, and I'll leave the curved surface until the very end. So starting this off, I'm actually just going to, I'm just thinking here, possibly the best way is actually to start from the plan view in this case, okay, because I've already got the width here. So starting with my plan, okay, I'm going to project out the width, which is 40 millimeters long, okay, and the front surface, I know that portion right there is 40 millimeters high, so that's the first one I'm going to start with. I'm going to keep it close to my plan, so right there, that's my end piece, so I'm actually going to heavy that in. And I know that is 40 millimeters, so I'm just going to measure 40 as it was folding down flat on a piece of paper. Okay, and that connects onto the front, so I know it's connecting on, or sorry, that connects onto the bottom, I should say. So I'll put in my hatched line there just to have it done. I'm going to heavy in this portion and this portion. Okay, don't want to get too far ahead of myself. Now that front bit is connected onto the bottom, okay, and that bottom there, I could take it straight from the sheet, okay. I know it should be about 80 millimeters, okay, because it said 20 plus 60, 20 plus 60, but what you could do is, you could also just take that distance on your compass, from there to there, and then from here, step it off, and having stepped that off, once again, put it in, and once again that would be another fold line. Okay, so far we have the front done, put a little kind of line through that. I've got the bottom done, and now I'm actually going to move on to my 2 sides. Okay, so the sides essentially will be coming straight up and they're going to fold down and fold down flat. Okay, so for this one it's actually going to be the exact same, and then on the opposite side it's just going to be kind of an inverted version. Okay, so to complete that, I'm going to connect it on, yeah, right here. So I'll continue on my line. Heavy this up, and I'm essentially redrawing this elevation here twice, okay? Like it is up here, and then kind of flipped over on the bottom half. So I'll extend that up, mark in my 20, okay, mark up my 40 millimeters. Just heavy that in there, mark in my 20. And then connect this down to here, and then finally, and I'll put this in heavy at the start, save me a bit of time. Just setting on my compass here. I'm going to take the radius from over here, which was 30 millimeters, and I'm going to mark it up from here to find my center, and then draw in my semicircle. So there's that portion done, and finally, while I'm at it, actually, I will just set it up on the bottom side as well, just to have it done rather than switching out my compass again. So same distance, going to mark out down 30, and then draw in my semicircle as it would appear on the opposite side, just to have it done. Saves me a bit of time. Okay, and then at that point there, what I will do now is up here, I'm going to connect this down to here, and I know it connects to here, and finally I know it connects also down to here, and then obviously the line connecting them is a fold line, so I'm going to put in my hatch lines there. So that's one side almost done. I still have to include the hole there. Now we will complete the rest of it on the opposite side. So same thing, mark up here, and actually just project this straight down, and then at that point I am going to mark down 40 millimeters because this is the inverted version, so I'll mark that to there, and at that point there I know it connects all the way down to the bottom portion of the diameter, or in this case probably the top portion, and at this point here then I can connect that to there and that to there. Okay, so as you can see, the idea is that it would all fold back together. This surface would fold up, this surface would fold up here like this one would fold up like this. Okay, so obviously another fold line is needed in here, and just before I move on to the final portion of this, okay, because we almost have the two sides done, so I'll just tick them off kind of, I have to also put in my radius 10 hole, okay, that's in it. Okay, so I'll just mark that there, have that ready, and once again a little bit awkward obviously with such a small, so once again as best I can. I'm happy with that one. Come down to the center for the opposite one, the exact same radius, try not to slip, and there we have it. Okay, so front, bottom, side, side. Now we have to do the back here, which is the curved surface. Okay, and the curved surface would obviously fold out like kind of as I described in another video. If you were to roll a piece of toilet paper, it would leave a trail behind it. Okay, and what we have to do is we have to create that trail. So what we have to do is we have to see in what view over here do we kind of have the semicircle. We can see it's in our elevation. So what you do when you have that is you're going to split the semicircle up into 30, 60 degrees. And because we only have a semicircle, we're going to divide it up into 6 portions, okay, or 6 segments. So 30 degrees through the center here, 30 degrees through the center here, 60 degrees through the center here, and then finally 60 degrees here. Okay, so I'm going to use labels now. So using labels, I know that this edge here is connected at the bottom. Okay, so in this case I'm going to call that number 1. I'll call this one number 2 on the outside, to 3, to 4, to 5, to 6, all the way up to 7. So we have to step it off about 7 times, okay, so that we have 6 sections inside here. So what we do is we take the distance with our compass from 1 to 2, okay, 1 to 2 like this, okay, which would be the same distance as it is from 2 to 3, 3 to 4, 4 to 5, and so on. And the reason that is because every one of these internal angles in here is 30 degrees. Okay, therefore, because they're all the same angle, the distance between all the points on the outside circumference has to be the same. So once again, just using labels, I know 1 was down here at the base, so technically my 1 is here and here. It's right there and right there. So I'm going to mark off to find number 2. So 2 will be there, to 3, to 4, to 5, to 6, and finally then to 7. Okay, and at that point there, I know that's as far as it goes out to. So at that point there, I will heavy in my curved surface. And just to show then, as I explained in the previous video, it's kind of like we have generators, okay? These are kind of the sections then, obviously, as they're running down along it, okay? So I'll just connect those. They do not have to be heavied in, but it's good to show them, okay, or hatched in, because technically they're not fold lines, they're just curved, okay? So at this point here was number 2, to 3, to 4, to 5, to 6, and finally to 7. Okay, so there we have it, guys. Just take that one off there once again. Okay, you don't have to do that, obviously it makes the drawing probably a little bit less tidy, okay, but if you want to just give yourself a little guide to go by, it's quite helpful. Okay, so just on that there, guys, elevation drawing, plan drawing, and we guided ourselves with here kind of making a little table then on what kind of surfaces we had to draw out, and basically the front, the bottom, the side, and then this curved surface here, okay, is probably the most important part of this question. And being able to do that, we had to come over here to our elevation and split it up, okay, into 30, 60 degrees, and then take the distance from 1 to 2 and step it off the amount of times until we reach number 7. Okay, and when you reach 7, we know that's the top of it, and that's kind of where it would obviously all kind of fold back up onto itself. Okay, and it obviously meshes up then with all of these sides here. Okay, that's the question done there, guys, and I hope you found that helpful. Okay.